In today's class, we are going to talk about differentiation. Differentiation is a branch of mathematics that was introduced by Leibniz Faraday and Isaac Newton. We shall start our discussion by considering the gradient of a straight line. Let us consider this graph. We have line PQ, which lies across points A and B. Now, if you look, this point from point A contains both x and y axes. For point A, I have x1, y1, and for point B, which is this, we have x2 and y2. So, if you want to find the gradient of P and Q, the gradient is given by increase along the vertical axis all over increase along the horizontal axis. You understand? Increase along the vertical axis all over increase along the horizontal axis. You understand? So if you want to calculate the gradient of line P and Q when we are given 2 points A and B, line P and Q lies across 2 points A and B. Are you getting it? So in order to calculate the gradient of this line, we make use of that formula. And increase means the vertical distance. That is rise. The vertical distance. That is rise all over run. Do you understand? So now when we are given 2 points, and we are told to calculate the gradient, we are going to use the formula, which is the y. Change in y will be y2 minus y1. That is the difference between this and this. Are you getting it? That is y2 minus y1 all over the change in the x. Are you getting it? The change in the horizontal distance. That is the run. Are you getting it? So that will be x2 minus x1. x2 minus x1. You understand? So, and don't forget that I want you to take note. When we are dealing with gradient, we are also talking about slope. Are you getting it? So the slope of this line can be easily calculated when we are given the value of x1, x2, y1, and y2. Let us look at a practical example. Okay. Now let us find the gradient of this straight line. We have the first question, which is point P and Q. Are you getting it? So the first step is that we are going to identify our x and y. Are you getting it? Our x1, y1, and our x2, y2. For this first question now, let's start with the first question. We have P, that is minus 2, 4, and Q, that is 3, minus 1. So for this is my x1 and this is y1. Since any coordinate consists of x, y, are you getting it? X, y. So this will be what? X1, this will be y1, and this will be x2, and this will be what? y2. You understand? And now, having identified our x1, y1, and x2, y2, the next step is that we are going to proceed to use the formula for gradient. Now, the formula for gradient is given by this. Gradient is also known as what? Dy all over dx. That is change in y all over change in x. That is y2 minus y1 all over x2 minus x1. You understand? So dy all over dx is equals to y2 is what? Y2 is minus 1. That is minus 1 minus y1. Y1 is what? 4. So minus 1 minus 4 all over. Then x2. x2 is 3. So I'm going to have 3. This minus x1. x1 is minus 2. So I'm going to have a bracket here, minus 2. For this, I'm going to have dy all over dx is equals to minus 1 minus 4. That is what? Minus 5. So I'm going to have minus 5 all over 3 minus 2. Minus multiplied by minus. That will be what? Plus. So I'm going to have 3 plus 2. That is 5. You understand? So dy all over dx is equals to negative 1. So the gradient of this line P and Q is what? Negative 1. Are you getting it? So now let us attempt question number 2. Okay, let's find the gradient of this point. We can see that the formula for gradient is given by this: y2 minus y1 all over x2 minus x1. So the first step is that we're going to identify our x1, x2, and y2 and y1. So for this is x1, this is this is x1, this is y1, this is x2, and this is y2. Do you understand? Because this is the first point, this is the second point. Okay, let us proceed. From this formula, I can proceed as this: dy over dx, which is what? The gradient is equals to y2. y2 is 8, so I'm going to have 8 minus y1. y1 is what? 7. 8 minus 7 all over x2. x2 is 5, so I'm going to have 5 minus x1. x1 is 3, so for this I'm going to have 3. dy all over dx is equals to 8 minus 7, that is 1. 5 minus 3, that is 2. So the gradient of this line is what? 1 over 2. So let us proceed to the third question. Okay, we have question number 3. To determine the gradient of this straight line, we have to first know our x1 and y1, x2 and y2. So this is x1, this is y1, and this is x2, and this is y2. You understand? So having identified our x1, y1, x2, and y2, we can proceed to use what? This formula. So dy all over dx is equals to y2 minus y1. That is y2, which is 9, minus y1, that is 4. All over x2, which is 6, minus x1, that is 2. So dy over dx is equals to 9 minus 4, that is 5. 5 all over 6 minus 2, that is 4. So dy over dx is equals to 5 over 4. You can proceed to leave your answer in decimal form, or you can still leave it in fractional form. But if you want to leave your answer in decimal form, it's okay. But I prefer the answers to be in fractional form, you understand? So now let us proceed to question number 4. You can attempt this based on what we have learned in the class. You can attempt this now. You can attempt this number 4. That is, the first step is that you are going to identify your x1 and y1 and x2 and y2. You understand? So this will be what? X1, this will be y1, and this will be what? X2, and this will be y2. Now, after identify your x1 and y1 and x2 and y2, you can proceed to use the gradient formula. Always remember this formula when you are dealing with the gradient of a straight line. Are you following? Always remember that formula. It's very, very important. So now in this class, we've been able to talk about what is meant by gradient. Gradient is meant by slope. I get what I'm saying. The gradient is meant by slope is not the same thing as gradient. Gradient tells us increase in y all over increase in x. That is rise all over runs. Increase in y all over increase in x. And when we want to measure increase in the vertical axis, we make use of the change. That is why we come about dy. You understand? Change. That is change. The difference between 2 points. Change. And all over the change in. Oh, sorry. This should be not dy over dy. This should be dx. You understand? Dy over dx. That is change in y all over change in x. Are you getting it? So increase all over runs. Increase in y all over increase in x. Are you getting it? So that is what is meant by gradient. That's the summary of the gradient of a straight line. Now, the next thing we are going to talk about in our next class is how to find the derivative of a function using the first principle and the power rule. You understand? How to take the derivative of a function using the first principle and the power rule. So stay tuned. Thank you very much. See you in the next class.